So the first section we looked at were all the examples and some applications around big data analytics in different industries. We looked at healthcare, we looked at telco, we looked at financial services. I think these are three areas that have really taken to using big data, and they realize what the value is. I've shown you a couple of examples, but there are many, 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 many more examples we're seeing in those industries and a lot of other industries. But I think for you as leaders, it's critical to understand what is the value, what are the benefits of getting involved with a big data analytics project. So we wanted to first talk about what are some of the drivers for advanced analytics. And these are not really new drivers, I would say. But I would say people are realizing there's an opportunity to capitalize on doing these much better and much faster. So if you think about these on the left, these are kind of like evergreen business questions, right? It doesn't really matter the year. You're always going to want to optimize your business operations. You're always going to want to find new business opportunities, right? So, but I would say when you have economic changes, when you have shifts in terms of what the economic climate looks like, there's increased emphasis to be better at this and do it faster and cheaper and with fewer people. So if we look at things like optimizing business operations, an example would be to optimize pricing, to optimize profitability. So maybe classic portfolio management and simulations, right? Looking at product mix and figuring out what's the optimal product mix to get the best pricing and the best number of sales in a given scenario. Or identifying business risk. We looked at a customer churn example. Actually, we looked at two, one on risk, one on churn. But people are looking at likelihood of fraud, likelihood of default. In many ways, this is linked to this bottom one, which is compliance and regulatory laws and requirements. In the financial services industry, I've listed a few laws, but certainly there's lots of other laws and requirements that are coming up. And with these comes requirements for data retention, for analyzing and reporting on some of the data you're keeping to demonstrate you're on top of it, very specific kinds of analytics that you have to do. So risk analytics actually is growing quite a lot in this area and is applicable to a lot of different industries. The one I skipped over is predicting new business opportunities, upselling, cross-selling, thinking about who your new prospects are. Again, these are old questions, but we're getting a lot better at how you do that. Partly this is because we've gotten great at the algorithms and the techniques, and partly the opportunities that big data provides means we can really be much smarter about predicting human behavior as it comes into these. There's a lot of people who are really saying big data is really about modeling and predicting behavior. So whether it's behavior in selling cycles or behavior in who is highest risk to get different illnesses or diabetes, whatever those things are, people are getting a lot better at predicting how people behave and react in certain situations. So I'm going to talk about four main kinds of benefits of these projects. Financial, improved decision quality, improved data quality, and collaboration. So for financial benefits, this was taken from two separate studies. The bar chart is by Nucleus Research, where they looked at what is the ROI of data science projects. And they looked at this and said, for hotels, the payback was very high. It was 1,800%, or about $18 back for every dollar spent on these kinds of projects. And the reason that was so high is they could look at things like, what other events were happening at certain points of time, what was the seasonality of hotel booking rates, optimize pricing, optimize hotel staffing. So there are a lot of constraints where they had very heavy costs and very heavy operational costs that they could reduce if they optimized this and looked at this properly. But overall, the average was greater than 10 to 1. I mean, your payback is greater than 10 for every dollar you're spending, which is really high. Think about the other kinds of projects you have to justify ROI for. Usually, people are satisfied with 2 to 1, 1.5 to 1, 30% gain. Here we're talking 1,000% gain, 1,800% gain. These are huge numbers. The bottom is a quote by two MIT professors in a Harvard Business Review article from last October, where they showed that companies who are in the top third of being data-driven in terms of the way they make decisions, the way they analyze problems, they're 5% more productive and they're 6% more profitable than their competitors, than their peer group. So 6% more profitable, that's That's a bottom line profitability, right? They're looking at things like earnings per share. They're looking at things like bottom line operating income growth. They're looking at things now like executive compensation, CEO compensation. So they're saying if they take a data-driven approach to looking at CEO compensation, what's the correct mix of options, straight salary? What are the correct mix to optimize long-term payouts and short-term payoffs, and how does that align to the growth of the company? So they're doing a lot of these kinds of studies right now. But it's been very clear, I would say, the evidence that the payback on these kinds of projects is very, very high. The other is the decision quality we talk about. So just by the nature of these projects, they have to be collaborative. It's not, someone who's excellent at algorithms sitting quietly in a dark room, pounding it away at a keyboard, right? By their nature, they're going to have to work with domain experts who know their business. They're going to have to work with other kinds of technical and business people just so that they can get the answers they need to understand what the problems are very well. I said this yesterday, but someone sent me a quote by Albert Einstein, and he said if he had an hour to save the world, he'd spend 55 minutes understanding the problem and 5 minutes trying to come up with answers and solutions to it, right? So part of this is just getting super clear as to what is the problem and driving consensus as to what is the problem and what's the right kind of solution for it. But that's one really big benefit. A lot of people work on problems or they track KPIs, key performance indicators, and they may have very low information value. It's just habitual to track certain kinds of measures because they've been tracked a long time, right? And sometimes this happens. But the other is, you can really measure the business value of certain kinds of decisions. One I see is people simulating what are events of if you buy a competitor or you merge with a competitor, what do the outcomes look like? Which ones are the most beneficial? So you can model these scenarios and think about what's the best benefit, and you can measure what is the financial value of making certain kinds of decisions, even when the decisions seem very qualitative. There's an excellent book on this called How to Measure Anything, where this person, Doug Hubbard, he basically looks at measuring all kinds of intangible things, whether it's risk or uncertainty or innovation, all kinds of things. And I would say this isn't done enough in most businesses in terms of understanding what is the value of having better certainty around certain kinds of decisions. But doing these projects let you do that, right? And the third is kind of what I was saying, right? You can quantify and reduce the amount of uncertainty. One of the things in that book is he'll say, well, if I want to make a decision, I need to know these 5 things. So let's imagine I don't have those 5 things. What else can I do? I can get experts. I can estimate it. I can calibrate experts. There's ways to calibrate what the estimates are. And maybe for 4 out of those 5, I can get a pretty reliable consensus of the estimates. But the 5th one, I may actually need to do a study to actually measure that. But if I can get those 5, I can go from being very uncertain to reasonably certain about the kinds of decisions I can make. And sometimes that doesn't require any modeling at all. It just requires being very creative about how you measure certain kinds of things. All right. The other benefit is really data quality. This quote by Supreme Court Justice Louis Brandeis, he said, "Sunlight is said to be the best of disinfectants." So what this means is, you can kind of be operating in the dark, and when you shine a light on something and you're forced to actually use it and interact with it, that's actually the biggest step forward to being forced to clean up the mess, right? So here, I've seen a lot of situations where people are reporting on data and they're looking at highly aggregated sources of data, and they're used to seeing these numbers over and over and over. But when you're forced to actually go into the details and you're really forced to look at the disaggregated data, you'll find all kinds of surprises when it relates to the quality and the consistency of the data. So doing one of these projects will force you to examine it, and you'll find a lot of issues. So the real question is quantifying what's the impact. How much effort is it worth? What is it worth to you to clean this up, and how long will it take to do that? And how can you prevent it in the future? So even just using this data in these kinds of projects are going to create the need for a little bit more formalized oversight on data quality or data quality programs. In the other courses that we teach, we talk about an analytics lifecycle. And as part of that lifecycle, we generally say that just conditioning the data will probably take you 75% of the project time, right? So people get really excited about creating the predictive models, about finding new insights in the data. But the reality is probably 3/4 of the time you're just spent munging data, cleaning data, sorting data. You know, you have to get really good at that and realize that's going to be the lion's share of the time. And I would say that's actually one shift with data science projects. I used to actually do a lot of work with economists in past roles, and you know, they were fantastic at modeling, but they had zero interest in doing the data conditioning. So the deal was, you know, a team of people that I worked with, they would do all the conditioning, and they would share the data once it was in certain kinds of structures and formats, and they would take it from there. But I would say a lot of these projects, you know, now you can't really decouple them. I would say that's actually become part of the decisions of how you do the analysis, right? If you think back to the telco example, you might decide to aggregate that data and look at, you know, things like how many phone calls, how many minutes did someone call. But you have to get to the very detailed data of who's actually calling each other, what time of day are they calling each other. And you have to get to that very granular level to do some of these more robust analysis, right?
Can you talk a little bit about what that means when you're dealing with big data?
Yeah, so I guess the short answer is it depends on the project, right? Some projects it may be sufficient just to query for keyword terms, right? Like flu or sick or certain kinds of symptoms. You know, if you look at Google Flu Trends, go to their website, you'll see what they're doing is making projections, correlating people searching and querying for certain kinds of flu-related symptoms and terms, and what's that relationship look like with the incidence of actual flu cases. So when they did this, they could do this much faster than the Center for Disease Control, and they could still do it very accurately, right? So what they're doing is they're looking at what are the terms related to a concept like flu, right? Is it sneezing? Is it runny nose? Is it cold medicine? Is it rest? What are those things? And look for the relationships of those terms. So in some cases, you're going to, you know, keyword may be sufficient. Other cases, you're going to want to look at the sentiment, like we said, of online reviews. Are they saying a lot of positive things? Are they saying a lot of negative things? Are they saying a mix? So the net sentiment is, you know, neutral, right? You'll know pretty quickly. In other cases, you can actually take it really far in terms of the semantics of understanding what that data is. I don't know if you want to add anything to this or if other people want to add to it, but I mean, there are whole fields around natural language processing and computational linguistics, and you can take this really far, right? So.
I'd also say when parsing social data, because that's part of my job, you need to be aware of how lots of keywords have multiple uses and in very strange ways. When I search for my company name, which is a 3-letter acronym, I have discovered that this is also a particular tag used by the New York Times on most of their articles. So it will scan for this 3-letter acronym and it'll pull up a lot of New York Times articles because it's in the tagging of the link. So you need to know what's being used where and able to exclude certain things so you're not getting noise.
Yeah, so I mean, that's a huge thing actually, is to understand. I mean, the conditioning is a big thing. I mean, a simple example would be something like fraud detection, I think. I think it's a simple example, where maybe you'll look at credit card transactions and credit card statements, and you have a choice when you bring that kind of data into a database or a data warehouse to analyze it, right? So, you know, there's been incidences when I've done this kind of work in my past, and people will look at this and they'll say, well, I want to remove duplicate records. You know, I have someone who they've done the same transaction in the same store on the same day, so it must be a dupe. I'll just filter that out, right? I'll just bring in the unique records into the data warehouse to analyze. But, of course, when you do that, you're removing likelihood of fraud, right? You have someone buying the same purchase amount 25 times on the same day at the same store, well, that's a pretty good indicator that something is going wrong, either inadvertently or someone's stealing a credit card number and doing lots and lots of charges. So what you're choosing to consider as repetitive or likelihood for fraud, part of that's also your background and your knowledge and your expertise of, you know, what to you is a likelihood of fraud. What are early indicators of those things? So part of it is expertise. I think when it comes to things like cultural considerations, I think the language part is actually huge, because you know, there's another example we do in our 5-day course where we'll say, here's a set of text here's someone reporting it, and they're talking about, oh, this looks like a threat, or this looks like there are people coming, and then we unveil the rest of the news article, and it's about a UFO sighting in a rural part of the United States. But you realize that when people talk about certain events, they can use very general terms, and those can mean very different things, and you enter viewing that with different bias and different cultural background that you bring to it, right? And that can alter what the interpretation is. Just like when she was commenting about, filtering out certain kinds of news articles and certain kinds of things related to it, a lot of it you have to filter text for what are the key points. And you can look at things like, term frequencies and word frequencies, and there's a lot of methods to go about doing that. But context is important, and what the person brings to bear from their background is pretty important in how they look at it too, certainly. Excellent questions. All right, the fourth one we'll look at is collaboration. And we touched on this briefly before, but when you do this, and we're showing examples of people who are part of this team, project sponsors, data scientists, data engineers, database administrators, business users. Ideally, you want a team that can work well together, but also who has diverse opinions and diverse ideas on this. Right? If you get too much of the same kind of thinking, it's very difficult to create innovative ideas and new ideas, right? You'll get groupthink. So here we say, this can have diversified ideas. It will increase awareness across groups. It gives you a foundation for future analytics projects, I should say. So it's creating a precedent. You do this the first time, it's the first time you've ever looked at very detailed data, then it may be the first time you're reaching out to people and asking them a lot of questions about what does this mean, what does that mean, should I trust this column of data, the contents look strange, it's in, maybe this is lira, not dollars, because the numbers are funny numbers. So the first time you uncover that, you're going to also need to build relationships with people who understand the context of that data. They understand the quality of that data. And maybe they're granting privileges to you to access certain kinds of data tables that they didn't need to before because no one's looked at some of these kinds of things. So, you're also creating advocacy for data quality in different areas of the organization, because they should now also understand that having bad data means, it's impacting the kinds of decisions you're going to make. And some of those decisions made on bad data can be very costly. Any other questions on this? I think your comment about cultural considerations is probably even stronger in this area, I would think.
Yeah, David, I also wouldn't underestimate the amount of sort of silos of those team members, right?
Yeah.
So the first time you do a project, even the basic blocking and tackling of getting your data scientist access to data that they, is in another line of business or in somebody else's data warehouse, that's no small task the first time around. So you've got, as a sponsor or the project lead, you've got to do a fair bit of education to the kind of the ancillary groups for which you want to create this project. So, somebody thinking about going in this direction, you certainly don't want to underestimate that piece.
Yeah, there's a lot of change management associated with this, right? And I would even say diplomacy to a certain extent. It's one thing to educate them and tell them the value, but you also have to see it from their point of view. There's a lot of teams who, from the data scientist perspective and this team's perspective, they want access to as much data as they can get. They want, a lot of availability of data. They want aggregated data. They want raw, detailed data. They want, as much as they can get within the legal limits of what's reasonable. And I had someone from an IT group who said, I have to tell you, I'm actually instructed to do the opposite. Give you the minimum you need that I think you need to do your job. So, if you're asking me for 5 tables because you think those 5 tables of data will get you the best answer, I'm instructed to give you 1 table, or to give you 1 table and see if 1 table is sufficient, and have you come back and ask for tables 2 to 5. So from their perspective, they may see it as more risk, more exposure, more sharing. I think many times people will fall back in habits of not sharing data and think that they're being mandated to not share data. But if you really look at it, most of the time it's allowed to share the data. You just have to really be cognizant of, under what conditions, under what sharing, how will it be published, how will it be used, all those kinds of things. But, my experience is the best practice here, and it's been trumpeted over and over and over in these kinds of venues, is to share data to the maximum extent that the law will allow you, which is actually quite a lot of sharing, and more than most people are habituated to do. So I actually would say this is a huge thing. The other analogy that comes to my mind is someone I used to work with would say, you're building bridges with a lot of these people you haven't had to work with before. And generally, it's a lot easier to be the second person to cross the bridge than the first, right? First person puts down all the costs of the bridge. They're doing all the hard work to build those bridges. But then all the rest of the people who come later benefit from having those relationships. So being smart about building relationships and being sensitive to other people's interest in this is really critical to doing this well. Great point. Thank you.